So continuing our lesson on ratios, rates, and unit rates, if we look on page 88, we're going to look at the do you understand number 2. So it says Dorian buys 2 pounds of almonds for $21.98, 3 pounds of dried apricots for $26.25. And the question is, which is less expensive per pound, and then also how much less expensive. Okay, so when it says less expensive per pound, we're trying to find what the cost per pound is. Finding the cost per pound, we need to take the price divided by the number of pounds. So for the almonds, if we look at the almonds for 2 pounds, they tell us that that was $21.98. So if we want to find our unit rate, our unit price, if we divide our price by the number of pounds, that will tell us how much 1 pound costs. So if you divide that, $21.98 divided by 2, you get $10.99. And what that means is $10.99 for 1 pound. We can do the same thing with the dried apricots. It's $26.25. That's for 3 pounds. So if we take $26.25 divided by 3, so that is $8.75 for 1 pound, or $8.75 per pound. So now that we know what 1 pound costs for each of these, we can look at these and say that and in order to get that, we would need to subtract $10.99 by $8.75 is how we get the $2.24. Okay, again, even if this one's not even that simple, but even if you guys are just doing 10 minus 2 or something simple, make sure you always show your work, show your steps so you can get full credit. We're going to move over to number 4. So number 4, Crystal is comparing 2 internet service plans. So plan 1 costs $34.99 per month. Plan 2 costs $134.97 every 3 months. If Crystal plans to stay with one service plan for 1 year, which should she choose, and how much will she save? So for plan 1, it's $34.99 a month, and if we're going for 12 months, we can do $34.99 times 12. Again, show your work, then you guys can use a calculator to work this out. So $419.88. This is for plan 1. That's for 1 year, what our costs would be. So plan 2, they're giving us the price for 3 months. So one option would be to find the cost for 1 month. So if we do $134.97 divided by 3 is $44.99 per month. That's for 1 month. And then we want to know for 12 months. So you take $44.99 times 12, which is $539.88. So from that, then we could see that plan 1 would be cheaper. So assuming this service is pretty much the same, plan 1 would be the better route to go. And if we subtract those, it'd be $120. So we could say she would save $120 a year with plan 1. And there's some other different ways we could have done this. On plan 2, they told us for 3 months. So one option would say from 3 months to 12 months would be 4 times as much. So we could just take the $134.97 times 4, and that would tell us the year amount rather than having to find the cost of 1 month first. It's just saving us a step there. It's not a big deal, but just to mention it to you guys. Another option would be to look at the monthly costs. So they told us plan 1 was $34.99 a month. Plan 2 we figured out was $44.99 a month. So if you subtract those, that's a difference of $10 per month. $10 per month times 12 months is $120 would be another way. So several different ways that we can work this out to get the answer for that one. So if we look at number 5, Pam read 126 pages of her summer reading book in 3 hours. And Zach read 180 pages in 4 hours. So if they continue to read at the same speeds, will they both finish the 215-page book after 5 total hours of reading? And explain. So probably a good starting point here would be to find our unit rates, see how much they read per hour. So for Pam, 126 pages in 3 hours. So if you divide that and you get 42. So 42 pages per hour for Pam. And then we can do the same idea for Zach. And that would be 45, so 45 pages per hour. So that's telling us how much they could read in 1 hour. We could then take those amounts and figure out how much they could read in 5 hours. We just take those rates times 5. So for Pam, if we take 42 times 5 is 210. So Pam could read 210 pages in in 5 hours, which is not going to be quite enough. For Zach, 45 pages an hour. If you do 45 times 5 is 225. So he would be able to read 225 pages in 5 hours. So he actually then would get finished with this 215-page book with a little bit of time to spare. This is probably the most common way for people to work this problem out. Again, just to mention to you guys, there's a lot of times different options on how to work these out. Once you get these unit rates, another option would be you could take 215 divided by 5, which would basically tell us how fast they would have to read in order to get finished. So 215 divided by 5 is 43. So in other words, they'd have to read at least 43 pages per hour in order to get done. So Pam with 42 is not quite enough. Zach with 45 would be enough to get finished in the 5 hours. Alright, so if we look at number 6, Nora and Eli are making homemade spring rolls for a party. Nora can make 8 spring rolls in 10 minutes, and Eli can make 10 spring rolls in 12 minutes. So if they each make 40 spring rolls, who will finish first? So if you want to, when you guys do a problem like this, you can make fractions, or we can make a table here. If you want, you can make a table. So for Nora, we've got the spring rolls. I'll just call them rolls for short. And the number of minutes. And then same thing for Eli. And this is similar to the problem we looked at with the rabbit and the kangaroo rat in example 3. So Nora can make 8 rolls in 10 minutes. Eli can make 10 in 12 minutes. And the question is, we want to get to 40 rolls for each of these. So we're assuming they're staying on the same pace. And so basically what we can look at is trying to either multiply or divide in order to get to our new number of rolls. And then we'll do the same thing with our minutes, and then we'll be able to figure it out. So for Nora, to get from 8 to 40, we would have to multiply by 5. 5 times the number of rolls is going to take 5 times the amount of time. So 10 times 5, that would be 50 minutes that it would take her. For Eli, going from 10 to 40, it's 4 times as many rolls. It's going to take 4 times as long. So 12 times 4, that would take 48 minutes. And so the one took 50 minutes, the other one took 48 minutes. And so we can see that Eli would finish 2 minutes faster. Workbook page 21, we're going to look at a few problems here, starting with number 1. So 3 boys for every 6 girls at a movie. If there's 24 girls, how many boys are at the movie? So 3 boys for 6 girls. We can make a table here. And then kind of like what we just did, if you look, going from 6 to 24, that'd be 4 times as many girls. So 4 times as many boys if we keep that same proportion. And then, so that would be 12 boys. Another way we could do this is we could say there's 2 times as many girls. So you could think, what times 2 to get 24? Or we could go the other direction and say there's half as many boys as girls. Since we know the number of girls, and then we could take 24 divided by 2 would be 12. So different ways to figure that one out as well. Number 6, at the supermarket, a 6-ounce bottle of salad dressing costs $1.56. A 14-ounce bottle costs $3.36. And a 20-ounce bottle costs $5.60. So cost per ounce, we take the cost divided by the number of ounces. So $1.56, we're going to divide that by 6. The $3.36, we're going to divide that by 14. And the $5.60, we're going to divide by 20. And then we're going to see which one's lowest cost per ounce. Again, not necessarily the best deal, because if we don't need to use this much salad dressing and it gets wasted, then we actually spent more money. But if we're going to use it all, we'll see which one's the best deal here. So $1.56 divided by 6 would be 26 cents per ounce. The second one, for the 14 ounces, if you divide that out, would be 24 cents per ounce. And the last one, if you divide that out, would be 28 cents per ounce. So comparing these, the least or lowest cost per ounce would be for the 14-ounce bottle. And again, we could make a nice sentence explaining about that. Number 10, Alan is mixing red and yellow paints to make 2 different shades of orange. To make 1 cup of dark orange paint, he needs 7 ounces of red paint and 1 ounce of yellow paint. To make 2 cups of light orange paint, he needs 13 ounces of yellow paint and 3 ounces of red paint. So for the first part, Alan buys a 32-ounce can of red paint. Does he have enough paint? Enough red paint to make 3 cups of dark orange and 3 cups of light orange paint. So if we look at this for the dark orange, look at the red, the dark orange, we need 7 ounces for 1 cup. And the light, we need 3 ounces for 2 cups. And the question is, we're trying to make 3 cups of both of these. So the dark is set up pretty nice. We know for 1 cup, so 3 cups, we're going to need 3 times as much. So 7 times 3 would be 21 ounces of red paint. The light is not set up quite as nice because we know for 2 cups. Probably what we want to do is go ahead, if you go ahead and divide that out, figure out how much we need for 1 cup. So 3 divided by 2 would be 1.5 or 1.5 ounces per cup. And then now we can get to our 3 cups. Same idea, it'd be 3 times as much as we need for 1 cup. So we multiply by 3. So that would be 4.5 ounces for the light. And then we can just add those together. When you add those, make sure you line up your decimal points. So we would need 25.5 ounces of red. So we could say that yes, we would have enough red paint, and we could even figure out how much extra we would have. We'd have like 6.5 ounces left over. And going through for part B, it's the same kind of idea. If you worked that out, they would need 22.5 ounces of yellow paint. So this gives you an idea how to work with ratios, rates, and unit rates.